Hello, this arrived yesterday. I've been thinking about buying one of these for a couple of years. If you haven't guessed what it is already, it's nano VNA. But I've been sort of looking at these for a while, as I said, but I didn't really like the earlier models. They tended to have, I think, a 2-inch screen. This one's got a 4-inch screen. By the way, it's the SAA-2N. And the other thing I didn't like about those earlier ones, or cheaper ones, was the fact that they used SMA connectors. I'm not a big fan of SMA. I prefer BNCs and N-types. As you can see, this one's got 2 nice N-types on it, which makes it easier, I think, to use. And you've got 2 ports on it. This is the channel 0, which is used for reflective measurements, and then you've got channel 1, which is used as a source when you're measuring something like a filter between the 2 ports. And I'm quite impressed with the construction of this. Some of those earlier nano VNAs just seem to be 2 circuit boards joined together one above the other with no proper case around them. This is a really solid aluminium case. Only thing that's a bit annoying is they've used what look like countersunk screws, but they haven't countersunk the holes they go in, so they tend to stick up a little bit, but it is what it is. And that's the power switch on the side, and you've got a couple of 3 buttons there. These really are to do with, the centre one is for the menu options, and the left and right is for selecting different options in the menu, or it will move the marker around on the screen, which is better than trying to drag it or touching on it. And I'll just show you what came with it in its box. So it comes in this nice little box, and in here we have a couple of cables which look like fairly high quality, low loss, RG142 it says. So that's what you'd use if you were going to connect a filter or something to the VNA. You'd connect one of these to each port and put the filter in the middle. And apart from that, we've got barrel connector, so you can normalise it by connecting the 2 cables together before you do any measurements. And then we also have a set of calibration loads. We've got an open, which is absolutely nothing in there at all, as you'd expect, and we've got a 50 ohm load, which is fine. But I was supposed to have a short as well, and what did they give me? They gave me another 50 ohm load. So I can't be bothered to complain, it's just too much hassle. So what I've done is I've taken this what was a load, and I thought I can get some thin copper sheet and cut it into a disc and drill a small hole. It's a bit smaller than the actual N-type pin, and stuff that down inside that socket so it makes good contact with the pin and the earth. And it's going to be fairly low inductance as well, very low inductance, which is the main requirement for a short circuit when you're testing at high frequencies. And I've had to stick a label on it saying short, but that's that. It's fine for what it is. And it cost me £76, by the way. And the frequency range of this one. The earlier ones were, I think, maybe up to 900 megahertz, something like that, or maybe less than that. This one supposedly goes up to 3 gigahertz, and it does something a bit odd. When you go above 900, it seems to switch to a different mode. So they're obviously doing something, some sort of bodge to make it go higher, because it doesn't give you such a good return loss above 900. But most of its life is going to be spent way below a gigahertz anyway, so I'm not too worried about that. So what should we do now? We could turn it on, I guess. And it's now sweeping. Again, a lot of reflections. You have to just make the best of that, I'm afraid. Don't know how to overcome that, really. But tell you what is slightly annoying is whatever frequency you've set it to cover when you've been using it, and you turn it back on again, it always defaults, don't know if you can see, to a start frequency of 100 and stop frequency of 900. So every time you turn it on, it resets to that range. It's not a major problem, but it's slightly annoying. There may be a way of storing whatever stuff in it. And you also get this guitar pit for using the touchscreen. But as I've got a fairly nice nail, I'm using that. So if I do touch on the screen now, I can do various things. I can do stimulus, and I can set my start frequency. And this is the other thing that's slightly annoying. If I set start to say 140 M for megahertz, now it goes back to that screen again. So I've got to do that again to set my stop. So now I'll set it to 150 for the megahertz stop frequency. So now it's scanning between those two. But I think I'm not going to do a full review of this. I'm just going to, because other people have done reviews on these and have probably done a better job than I can. But it's just going to be a quick introduction to it, and try it on a couple of aerials, 2 or 3 aerials. And of course at the moment I'm in what it calls log mag, which is return loss basically. And if I stick a 50 ohm load on that, as you can see, that's that particular frequency of the marker, which is 143 megahertz. I'm getting a 65 dB return loss, which is almost sounds too good to be true, but whatever. But the other thing we can do with it, we can go to display and format, and I can now display SWR. So I'm now in SWR mode, and it's saying I've got a 1-to-1 SWR, which is exactly what you expect with a 50 ohm high quality load. And I can also of course go into Smith charts, and it's sitting right on the center line, because where's my pointer gone? Anything this way is going to be inductively reactive, and I think it's this way for capacitive reactive, and in the middle is just resistance, pure resistance. And as you can see, or may be able to see, it's saying 50 ohms and capacitance of 630, well, it's jumping around, 36 nanofarads. Well, I don't know how it manages to find a 36 nanofarad capacitor in that load, but whatever. But Smith charts are not really my scene. I'm more interested in return loss and SWR, which are basically interchangeable anyway. I could go through the calibration routine on the open, short and load, but I don't think it's worth doing because other people have done the same stuff on it, and there is no operating instructions with it. You more or less have to work it out from, you get a bit of paper with the menu structures, so you've got to know what you're doing to a degree when you're making measurements like return loss and SWR and whatever. I haven't been through all these options on this screen yet. I believe there's options to store stuff, maybe able to store frequency sweep parameters. I don't know at the moment. I've only had it yesterday, so I'm still getting familiar with it. So all in all, I think it's, for the price, a very nice little unit. And looking at the back again, it's got 3 LEDs on at the moment. There are actually 4, another one there, and they indicate the state of the battery, and they'll go down to 1, and then you know your battery is nearly dead, and they flash as you charge it. And it's got a USB charge connection there, which sadly is not a USB-C, which is a bit annoying because everything these days is USB-C, but it's not too bad anyway. So what I think I'll do now is I'll set up a test aerial, and we'll look at how it performs on that aerial, or how the aerial performs. Okay, here's the first antenna I'm going to test, and there it goes all the way up there. It's about 5 foot long total, and it's a 2 meter J-pole, which I built a few years ago, not for any particular reason, just because I thought I'd build one and see how good it was. And if you know what a J-pole is, it's basically an end-fed half-wave dipole. Of course, a half-wave dipole's got a high impedance if you feed it at the end, so you have to have a quarter-wave matching section, which is in the bottom part down here, quarter-wave matching section, and then the half-wave up there. So let's have a look at this screen. I don't know how well this is going to show up, but anyway, I need to set my frequencies. Start frequency I'll set to 140 megahertz. Stop 150. Okay, well that looks promising. Now if I move my marker with the switches, find the lowest point, I'm saying I have on the screen a 30 dB return loss, and that's quite a good match. If I go into SWR, you can see it's saying I've got a 1.05 to 1 SWR at 144.4 megahertz. So that is performing quite well, I would say. Of course, when you're testing antennas, you always got to be aware of anything metal that's nearby. But I can move the marker up, and 145.5 is 1.5 to 1 SWR, and the other way, of course, is similar. 143, yeah, okay. So this antenna, go away, antenna is resonant at 144.4, which is a little bit low for the FM part of the band, but as I said, it may be influenced by stuff around it. And we could also go on to the Smith chart, and there we see the resonant point where the marker is, and it's now saying it's a 50.8 ohm resistive load with 357 pF reactive, and that will change as you move the marker. So it's all capacitive, there's no inductive wherever you put the marker. Oh well, that's good. Anyway, we'll try another antenna now, I think. Okay, this next one is a 70cm collinear, which I built into the part of an old dual band 2-meter fiberglass collinear, and this was just one of the sections I used. And again, I built this just for experiment, really, no intention of really using it, but it seemed to perform quite well. In fact, I would say it was probably as good as my Diamond X510, but of course it's just a single band. And I don't remember how many elements it's got in it, or how much gain it's got. It might have about 3 or 4 elements inside it. Let's have a look at the screen anyway. So now I need to set up again my frequency range. So, start. I'm going to start at 420, I think. And stop. I think I'll stop at 450 megahertz. Okay, so that looks fairly good. Move my marker. It seems to be resonant at 435.6 with a return loss of 27 dB, which is fairly good. Do an SWR, display, format, SWR, okay. That's a 1.08 to 1 SWR, which is very good. If I move down the band a bit, at 430 megahertz, bottom of the 70cm band in the UK, we get 2 to 1 SWR, which is poor, and around 433 it's 1.3 to 1. I guess it's not too bad. And let's do around 438. 438, it's 1.4 to 1. So if anything, it could have gone down a bit lower in its resonance point. I wonder what the Smith chart will look like. Yeah, very nice squiggly line. Oh well, that seems fairly good. As you'd see, if I move it to the resonant point, it's now saying, ooh, its resonant point is, it's not 431. It's only 30 ohms. That's interesting. Okay, I get it. So the best match is there with 48 ohms and 130 pf. Okay, yeah, that makes sense, I guess. And if you go past there, it goes to 27 ohms. Yeah, interesting. If I go around there, 440, 37 ohms, 11 pf. 427, 20 ohms. Alright, but none of these arrows have got any inductive component. Well, whatever. Okay, back to SWR. That's fine. I'll do one more antenna. Right, the final antenna is a 21 element Yagi for 23 centimeters, which I built a couple of years ago, and I think it performed quite well. I think I did some measurements as best I could. It seemed to have about 15 dB gain over a dipole, but I was never too happy with the matching. It didn't seem to have particularly good match, but it did perform quite well, apart from the fact that it's hopeless here trying to work 23 centimeters because of all the hills around. So I quickly learned that to give up on 23 centimeters. Okay, so let's look at the VNA. So set the frequency. I'm going to start at 1.2 gigahertz and stop at, say, 1.4. So I'm looking for 1296 as the 1296 as the what's it called, resonant point. Okay, so we've got all sorts of weird resonances here. So we've got right down there, we've got one, and that is at 1236 megahertz. Right, okay. I've got to, say, 1290. Let's see, 1290. So at 1290 it's got a return loss of 17 dB, which I guess is a fairly good match. But let's try format SWR. Okay, so it's got a 1.3 to 1 SWR at that frequency. So it's not too bad, is it? Not too bad, really. If I get anywhere near it, it alters it completely. But that's a fairly good match in theory then. Just try the old Smith chart. Oh dear, what does that mean? Squiggles everywhere. Well, this antenna, it's got some inductive elements to it. In fact, at that point there, it's telling me it's 61 ohms with 11 pf. Okay, I can believe that just about. $55 ohms. If I go down to 1276, that's 59 ohms, and it's got 700 picohenries of reactive component. Oh well, I suppose it sort of makes sense. Interesting that this one's got some inductive reactance as well as capacitive reactance at different frequencies, whereas the others were entirely capacitive. I don't know what that means, but all in all, I think that's a fairly good test. I think that's all I'm going to do on this now. But to conclude, I think this is a very good unit for the price. And when you think back to when I was working in electronics, we used to use a HP VNA, and that would be, I don't know, 10, 15, 20,000 pounds. So there's just no comparison, is there? Obviously this hasn't got the same performance, but it's good enough. So bye for now.